Alright, so we have John. Don't you dare throw that, bounce that super ball over the house. Looks like he's going to do it anyways. So we have his equation because he's meticulously calculated this out. He thinks he can get this ball over the house by hitting it against the sidewalk. And we want to know if it's going to make it, long and the short. So obviously A is asking how long it will be in the air. We need that so that we can find the maximum. So to find the maximum, I first need the x-intercepts. How long was it in the air? So to factor this, we have 48t minus 16t squared. What goes in both of them? Well, 16 does. 16t. So I'm going to factor out negative 16t, so I get t minus 3. And that gets me positive, makes it a little bit easier. And at the x-intercepts, the y value is 0. So I'm going to break it apart into its pieces, and I get t is equal to 0, no big shock. 0 seconds it's on the ground, right? And it is in the air for 3 seconds. Well, if it's in the air for 3 seconds, that means its maximum is at 1.5 seconds. So let's plug that in. So instead of t, I'm going to write 1.5. So here we go. 16, that's negative, times 1.5 is going to give me negative 24. So I have negative 24, and I'm going to multiply it by 4.5, which is also a negative. And so it is 108 feet above the ground. That seems shockingly high. And it is, because 1.5 minus 3 is not 4.5. 1.5 minus 3 is actually 1.5. So I'm going to multiply that times negative 1.5. Sorry. So 24, which is a negative. Shoot. Let's try clearing it. 24, and that's a negative, times 1.5, which is also negative. Gets me 36 feet. That is taller than the house. Now I'm glad that you saw me make a misstep, because I got an answer that was ridiculous. 100 feet above the ground for a Super Bowl is really, really high. Okay, Nico, I know that you're strong enough to do it, but for most people it doesn't seem reasonable. So going back once you get an answer that doesn't make sense is always a good idea.